function is, the block diagram of a feedback control system is shown in figure. The transfer function y of s by x of s of the system is, the given four options. You have to find the transfer function y of s by x of s of the given system. This can be done by using Mason's gain formula. Okay. So now we are going to draw the signal flow graph for the given block diagram of the control system. From that signal flow graph, we are going to find the transfer function y of s by x of s. For that, we are going to use Mason's gain formula. Okay. So before drawing the signal flow graph for this given feedback system, first of all, let me write the Mason's gain formula. Mason's gain formula. This is for the determination of the overall system gain. Okay. Mason's gain formula is used to determine the overall system gain. Gain is nothing but the transfer function. Gain is nothing but the transfer function. Then what is this Mason's gain formula? The gain T is equal to 1 by delta sigma K Pk delta K. What is Pk? Pk is path gain of kth forward path. And what is delta? Determinant of the graph. That is equal to 1 minus sum of loop gains of all individual loops plus sum of loop gains of all possible combinations of non-touching loops minus sum of gain product of all possible combinations of three touching loops plus etc. And what is here the term delta K? Delta K is the value of delta for the part of the graph not touching the kth forward path. Kth forward path. Okay, let me explain the Mason's gain formula. It is used to find the gain of the given system, and that gain is also called transfer function. This is the formula to find that gain, 1 by delta sigma k pk delta k. What is pk? Path gain of the kth forward path. Delta is determinant of the graph, and that is equal to 1 minus sum of loop gains of all individual loops. Means first loop gains of all individual loops. Means first you have to see the individual, you have to take the sum of individual loops. Then change the sign. Take sum of loop gains of all possible combinations of two non-touching loops. Then minus sum of gain product of all possible combinations of three non-touching loops. What is the next term? Plus sum of gain product of all possible combinations of four non-touching loops. In that way you have to extend. And then there is another term, delta k. What is delta k? Value of delta for the part of the graph not touching the kth forward path. Okay. You can understand the Mason's gain formula and how to apply the Mason's gain formula by taking a feedback control system. Okay. So now I'll see our problem. Let me draw the signal flow graph for the given system. Signal flow graph. Okay. Yes, first you have the input x of s. You have to represent this with a node. And then you have a summing point. This is a summing point. So take another node. Okay. Between this and this, you don't have anything. So take it as 1. And then you have another takeoff point. So takeoff point, let it be the node 1 and 2. Then after the takeoff point, you have again summing point. So take 3. And you have the output y of s. So now we'll fill all these things. So between the node point 1 means 1 and the 3, you have the forward gain G2. Okay. So now 1, 2, 3. This is nothing but G2. Okay. And next, between summing point and takeoff point and the forward path you have G1. Means between 1 and 2 you have G1. And from this takeoff point to summing point, you have the feedback H1. H1, and as it gets summed as minus negative feedback, just write it as minus H1. Okay. So between 2 and 3 you must write 1, and here also between 3 and the output node you must write 1. Okay. So summing point and takeoff point and this summing point, totally you have 3 nodes. So 1, 2, 3, 3 nodes. You have 3 nodes. 1, 2, 3. Between 1 and 2 you have G1. Yes, G1. Between 2 and 3 you don't have any 1. So 2 and 3 just it is 1. Between 1 and 2 there exists a feedback path, that is H1, and it gets added like minus. So it is simply minus. Okay. So now we'll apply the Mason's gain formula. What is that formula? Mason's gain formula. E equal to 1 by delta sigma k pk delta k. So now observe this signal flow graph. How many forward paths are there? This is one forward path. This is one forward path and this is another forward path. Two forward paths. Okay. What is pk here? Path gain of kth forward path. Sigma k into pk delta k. Pk is path gain of kth forward path. Two forward paths are there. This one and this one. What is their gain? The first one gain is G1 and the second one gain is G2. Fine. Next. How many loops are there? See here. Only this is the loop. Only this is the loop. One loop is there. This is the loop. And now if you see this loop, it is touching both the forward paths. It is touching this forward path and also this forward path, because this is the node which is connecting the two forward paths and this is the node which is closing the feedback path. So the same node is connected to two forward paths, hence there is no loop which is not connected to the forward path. Fine. So now what is your delta? What is delta? One minus. Actually, you have to know loop gains of all individual loops. First point, sum of loop gains of all individual loops plus sum of gain product of all possible combinations of two non-touching loops. Here in the given problem, we don't have extra loops. We have only one individual loop. That is the reason. Yes, just you can write 1 minus sum of all individual loops. What is the loop here? G1 and this is minus H1. So it is 1 minus G1 H1. We don't have more number of loops here. Only one loop is there, that is individual loop, and it is touching both the forward paths. Okay, so very simple problem. So I'll get only the first term of delta. 1 minus sum of all individual loops, because we don't have two non-touching loops, we don't have three combinations of three non-touching loops like that. So the delta becomes 1 minus only the loop gain of individual loop. Okay, what is the individual loop here? Only this one. So it is simply minus of minus G1 H1. So it is nothing but 1 plus G1 H1. Okay. So now what is your T transfer function? Here the transfer function is y of s by x of s. Okay. What is pk here? First path is G1. What is delta k actually? The value of delta for the part of the graph not touching the kth forward path. Here, delta, in the delta we have only one loop, that is G1 into minus H1. But it is touching the two forward paths. Okay. So, what about delta k here? G1 of, yes, you have to write this 1 minus. But there exists only one loop which is touching the two forward paths. So there is no loops which are not touching the forward paths. Hence it is 0. Same way. What is the second path? G2. This is second path G2. And you have to write its own delta k. What is delta k? The value of delta which is not touching the forward path G2. But we have only one loop in the delta which is touching G2. So hence G2 of 1 minus 0 divided by delta you have to write. What is that? 1 plus G1 H1. So what is the answer? G1 plus G2 by 1 plus G1 H1. So now what is the answer here? And the options? The answer is yes.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.